Hello everyone, I'm Haicheng Cao, and now is the integrating sphere training. And the integrating sphere we can see here is this one, and it's used to collect the light from emitted from the LED device or laser something else device. And it's because this integrating spheres can collect almost all the light and from the device, so it can get a very accurate value of the optical power and the luminous flux of the devices. And now we will start the training of this equipment. And before that, we need to turn on these two devices. And this one is the power source for the semiconductor device, and this one is the spectrometer. And and the measurement range of this spectrometer is from 200 nanometer to 800 nanometer. And here, this is the integrating sphere we will use. And before we open the software, we need to turn on these two devices and just click the power button here. And you can see here. And then we need to mount the sample on the sample holder. And what leads to notice is that the sample we will use is the packaged sample. It's not a bare LED chip or something else. So here we can see, and we need to make sure the electrode should be on the right position, and this one is the positive, and this one is the negative. And we can press and then put the sample in and relax it. And then we put the sample holder in the hole of the integrated spheres. After do this behaviors, after we will start the software. Now here, this one is the software we will use. It's named AV5. And double click, open it. And in this software, we can use the two different models. One is the normal text model, another one is the pulse text model. Usually the operation in these two models is similar. So now we will show you the normal text models. And we will need to wait for a few seconds to make sure the software is ready. Okay. And before we start with the measurement, we create the new project. And then type in the current you want to measurement, such as for the device we will type in 50 milliampere here. You can see, and then you will click the fast tester, and then we can see the tester is ready, and it wait for you to click the tester button here, and we just clicked it. Okay, and now it is start. Okay, we can see we already have the measurement result. You see here, and in this node we can see there are lots of information, and including the forward current and voltage and the electrical power, and we also can see the optical power here, and we also can see the luminous flux and other important information, such as the peak wavelengths. We also can see here. And this is the spectrometer of the devices. And okay, after we do the measurement, we need to export the data. And here, we just click the export files. And you can create a folder of by yourself. And now this is my name. And we can create a date. Okay, and rename these files, such as name the one, save it. Okay, now we can save all the important information in this list, and but we also need to save the spectrometer of these devices. So we need to export the spectrometer, and then we can rename it again, such as spectra. Okay. Now everything is saved. We can check it. Yeah, the two access file we can see here, and we can open one of it. Okay, now we already opened these files, and we can see this is the wavelength. It can use to be the x-axis, and this is the intensity of the spectrometer of the spectra, and this one is the absolute value of the spectra, and this one is the normalized data of the spectra. Okay. Here we also can see all the important information of the devices. We can see the current, voltage, the electrical power, optical power, and the luminous flux, and the peak wavelength, and lots of information here. So it's the saving data process. Okay, after we finish the measurement, we should click the fast test again, and then close the software. Yeah, and if you want to save the projector, you can click the save, and then save it in the file you want, and we can click here. Yes, we can here. This is the projector you have saved, and that's all.